Let's start this particular session, guys. So just we will discuss the formula completely, guys. What is our formula and what are these notation which is explained in the code or in the textbook. Okay, so let's start it, guys. First is the relation between the characteristic strength and the target mean strength. As you know that the characteristic strength is nothing as it is the strength below which 5% of test result are expected to fall, right? That is our characteristic strength. And what is target mean strength? It is the strength below which 50% of test result are expected to fall or it is greater. So the relation between FM and FCK is what? You can write here, guys. FM is equal to, let me use a different color so that everyone can see it properly. So guys, just a second, let me raise it. Okay, so what we can write here, FM is equal to how much? It is equal to FCK plus 1.65 sigma. Now what is sigma? Sigma is nothing as standard deviation, FCK is characteristic strength, and FM is a target mean strength value, right? Then the next relation which we need to understand is Young's modulus of elasticity. So you know that, guys, Young's modulus of elasticity, which is basically the short-term Young's modulus of elasticity, or it is also known as our secant modulus, right? So which is given by the code is 5000 under root of FCK. So this is basically our secant modulus of elasticity. Secant modulus of elasticity, or you can call it as short term also. Short term Young's modulus of elasticity. Modulus of elasticity. Let us suppose, guys, if we want to find out the long-term Young's modulus of elasticity, we need to use over here the creep coefficient, which is nothing as basically our theta, right? So long-term Young's modulus of elasticity, ECL, this is basically EC, right? ECL is nothing as 5000 under root of FCK divided by 1 plus theta. And what is theta? Creep coefficient, which will depend upon age of loading, right? Age of loading is nothing as our T duration. Now, what is age of loading? The time after which the structure will be loaded, right? So after 7 days, if it is loaded, then the creep coefficient, which is nothing as theta, it should be taken as 2.2. If it is 28 days, then it is 1.6. If it is 1 year, then it is 1.1. Okay. And let me tell you one more thing, guys. What is the value of ES, which is recommended by IS code, Young's modulus of elasticity for steel? It is basically 2 into 10 raised to power 5. Whatever type of steel, it doesn't matter whether it is mild steel or HYSD bar, you have to use the same value, which is 2 into 10 raised to power 5 Newton per mm square. Clear? Okay. Next thing, which is related to the design for flexure part. So let us consider this is a singly reinforced beam. Let us suppose this is width B and this is the overall depth capital D, right? Let us suppose this is our AST, area of tension steel, and the dia of this particular tension steel is phi. Okay. Let us consider this is our clear cover, which is basically CC, clear cover. Now what we need to do, guys, we need to calculate the effective depth, which is nothing as the distance of highly compressed fiber to the centroid of the tension reinforcement. That is our small d value, and this is our capital D value, which is nothing as overall depth, right? How we can calculate the small d? It is very easy. Small d can be written as capital D minus clear cover minus dia of tension reinforcement divided by 2, right? So this is nothing as our small d value. Now this one is what? Our strain diagram. So what is the value of strain? 0.0035. Now this one is Fy divided by 1.15 ES plus 0.002, right? And what is this? This is nothing as our stress. How much it is? 0.87 Fy into AST. If you multiply it, you will get the tension force. What is the value of compression force? Compression force is equal to 0.36 FCK B into XU. Clear? Right? All of you are able to understand? Now what is this distance? This is basically 0.42 XU. 0.42 XU. Now what is this distance? How much it is? It is nothing as our lever arm, and lever arm is equal to d minus 0.42 XU, and that is nothing as that is our lever arm. Clear? Now guys, the question is how we can find out the moment of resistance, how we can find out the actual depth of neutral axis, what is the formula for limiting depth of neutral axis. Let's understand. So the first one is limiting depth of neutral axis, which is nothing as XU limiting. XU limiting can be written as K into D. What is the value of K? K is nothing as limiting neutral axis depth factor. How much it is? It is 700 divided by 1100 plus 0.87 Fy. Right? That is our K. Right? Now what is the value of J? J is nothing as lever arm depth factor. So what is the value of J? J is equal to 1 minus 0.42 K. That is our lever arm depth factor. Question is how we can find out the actual depth of neutral axis, right? Actual depth of neutral axis. To find out actual depth of neutral axis, you need to equate C force is equal to T force, right? So C force is equal to T force, then you will get the value of XU, how much it is, right? So can I write here 0.36 FCK B into XU is equal to 0.87 Fy into AST, correct? So we can write here XU is equal to how much? It should be equal to 0.87 Fy into AST divided by 0.36 FCK B. And this is our formula to calculate the actual depth of neutral axis. Crystal clear? Very nice guys. Now the question is what is the value of K if we have different grade of steel, right? That means what should be the value of limiting depth of neutral axis depth factor, right? Limiting neutral axis depth factor, that is basically K. So the value of K will depend upon the grade of steel which you are using. If you are using Fe250, then the value of K is 0.53, Fe415 0.48, Fe500 0.46. Clear? Are you able to understand? So this is nothing as this is basically XU max, or you can write XU limiting, or you can write K into D. Clear? Okay. Now the question is, sir, how I can find out the moment of resistance? It is very simple. Moment of resistance for a singly reinforced beam can be written as C force into lever arm, or you can write here T force into lever arm. What is the value of C force? It is 0.36 FCK B into XU bracket lever arm is D minus 0.42 XU. Similarly, what is the value of T force? It is basically 0.87 Fy into AST bracket D minus 0.42 XU again, right? So these are the formula to calculate the moment of resistance. Crystal clear to all of you? Yes or no? Please write down in the chat box guys, quickly. And hit the like button as well as share this session to other students so that everyone can join over here, right? Tell me guys in the chat box. It is clear to all of you? Very nice. Now guys, the question is, sir, if we have different section like under reinforced section, balance section, over reinforced section, then what should be the condition and what should be the formula which we have to use to calculate the MR? Very simple guys, I have made one table by which you are able to remember it quickly. Okay, so let us suppose guys, if our section is under reinforced section, that means the actual depth of neutral axis is less than limiting depth of neutral axis. So while calculating the moment of resistance, you have to use XU, and you can find out the value of MR from the tension side as well as compression side, right? That means from both the side we are able to find it out. Next one is balance section, or you can call it as limiting section. Limiting section. For limiting section, XU is equal to XU limiting. You have to use XU limiting while calculating the moment of resistance. You can calculate the MR value tension side also, from the tension side also, as well as from the compression side also. It is your choice from which direction you want to calculate it. The next condition is over reinforced section, right? Next condition is over reinforced section. In over reinforced section, XU is greater than XU limiting, right? If it is greater, while calculating the MR, please remember this point guys, you need to use XU limiting only. Don't use XU while calculating the moment of resistance, right? But you need to remember this point also, guys. While calculating the MR for over reinforced section, always try to find it from compression side. If you find it out from the tension side, you will get a wrong answer, right? That's why, guys, please remember, you need to find out the MR from the compression side only. Clear? Very nice. Now, guys, there is one more formula which I want to explain over here. You know that one design formula most of the time we are using. Like, let us suppose if you have mu limiting condition, then mu limiting condition can be written as q into b into d square. Now, what is q? Q is nothing as movement coefficient. Movement coefficient. What is the value of movement coefficient? It is 0.36 fck k into j. You know that what is k? You know that what is j? What is fck? You know that, right? Already. So q is equal to how much? 0.36 fck into k into j. Okay, clear, guys? There is one suggestion from my side. There are some standard grade of concrete and standard grade of steel, right, which mostly they can ask in the examination. So what you have to do, guys, you need to just a second, if you just wait a minute, guys. Okay, so you need to what you have to do, guys, basically, please remember some of the standard value which I want to explain over here. Please remember it. Okay, so guys, what is the value of k if we have Fe415? It is 0.48, right? What is the value of j if you have Fe415, right? 1 minus 0.42 k. Kindly put the value of k, you will get 0.8. Clear? What is the value of q? Please remember these values, okay, so that you will use it in the examination directly. 0.36 fck k into j. Kindly calculate this value. So 0.36, consider fck is equal to 20, k is equal to 0.48. Clear? And j is equal to 0.8. Do this calculation and let me know the answer in the chat box, guys, quickly. बताइए जल्दी से. Please let me know, guys, what should be the answer for this thing. Tell me. How much you are getting? 2.76? 2.7648. So these are the design constant which you have to remember for M20 and Fe415 grade for your examination. These are nothing as basically design constants. Please remember it. Design constant. Okay, understood? The next one is basically our doubly reinforced beam. So you know that, guys, doubly reinforced beam is nothing as it is the section in which the compression and the tension reinforcement both are to be used while designing. Now this one is basically our ASC part, area of compression reinforcement. This one is area of compression reinforcement, and this one is area of tension reinforcement. Let us consider the effective cover for the compression reinforcement is DC, and the effective cover for the tension reinforcement is DT, right? So we will calculate the value of small d, which is very easy. Now, guys, in this particular doubly reinforced section, which is the most important thing, to calculate the strain at the level of compression steel, right? So you can see here, this is the strain value, which is basically ESC. So we need to calculate how much it is. How we can do it? By using the similar triangle concept. Let us suppose this is our actual depth of neutral axis XU. So what is this distance? This will become XU minus DC. Let's calculate the value of strain at the level of compression steel. So at XU depth, the strain value is 0.0035, and at the depth of XU minus DC, the strain is ESC. So ESC is equal to how much? XU minus DC divided by XU multiplied by 0.0035. So this is the formula by which you are able to calculate the strain. And after knowing the strain, you need to use the table to find out the value of FSC, which is nothing as stress in compression steel. stress in compression steel. Now, the question is, sir, what is the formula to calculate the moment of resistance in case of doubly reinforced section? So there are basically two forces. One is C1 force, and whose depth from the top is 0.42 XU, and there is a second force which is basically C2, whose depth is DC, right? Let us consider this is our lever arm 1 and this one is our lever arm 2. So just remember this formula. What is lever arm 1, lever arm 2, C1 and C2. You are able to get the value of MR easily. So guys, what is the value of C1? C1 is equal to 0.36 FCK B into XU. What is lever arm 1? Lever arm 1 is D minus 0.42 XU. What is C2 force? C2 is equal to FSC minus 0.45 FCK multiply by area of compression steel, and then we have lever arm 2 which is basically D minus DC. Now take the product of these values, you will get the moment of resistance. So moment of resistance for doubly reinforced section is C1 into lever arm 1 plus C2 into lever arm 2. Getting a point or not, guys? If you want to write it completely, you can write it down also, that like 0.36 FCK B into XU bracket D minus 0.42 XU, then plus FSC minus 0.45 FCK bracket ASC multiply by D minus DC. In this way also you can write it down. But guys, my suggestion is please try to remember the formula in this way, so that it will be more easy to solve the question and memorize the formula also. Crystal clear? Any doubt, guys? Any doubt? Please tell me in the chat box. Clear? Okay, very nice. Let's move to the next thing. So next type of section is basically our T-beam or L-beam. So guys, the most important thing in case of T-beam and L-beam is to find out the effective flange width, right? Which can be represented by B effective or BF, right? Let us suppose this is our B, which is the width of the T-beam. This is DF, this is our depth of flange part. This is D, which is overall depth, and this is BW, this is our width of web. So what is this? Let me write it down. This is basically web area, and this one is our flange area. Now, how to calculate the B effective? B effective can be written as L0 divided by L0 divided by B plus 4 plus BW. Now the question is, what is L0, sir? L0 is nothing as, it is the distance between the point of zero moment in the beam. Let me explain it. Let us suppose, guys, if you have a simply supported beam. So for simply supported beam, L0 is equal to L effective, right? But let us suppose, guys, if you have a fixed beam or continuous beam. So for fixed beam, the value of L0 will become 0.7 times of L effective. Please remember this condition also, right? After putting this and the value of B and BW, we are able to get the value of effective flange width for the isolated type of T-beam. For isolated type of T-beam. Similarly, guys, we will have a condition for isolated type of L-beam. So let us suppose if it is isolated type of L-beam, in that case, you just need to multiply it by 0.5. So 0.5 L0 divided by L0 divided by B plus 4 plus BW. You will get the B effective again, right? This is isolated type of L-beam. Next one, the effective flange width. The effective flange width for slab plus beam type. For slab plus beam type. Now guys, in this case we will have two formula which we have to use over here. Okay, so let's understand how we can use it. Listen, let us consider this is our slab plus beam type. That means our slab and beam are casted monolithically. That means they are casted as a single member, right? Okay, so let us consider this is basically BW and this one is our depth of flange, which is basically df. Now there are two distance which you can consider, and it is your choice also. So one distance which we will mark over here, guys, that is basically center to center distance between two beams. The center to center distance between two beams, let us consider that distance is L1 and L2. The second type of distance which we will mark over here is the clear distance between two beams. So this is the clear distance which you can write here, guys, as a L1 dash, and this is again clear distance which is basically L2 dash. Clear? Now what is our formula to calculate the effective flange width? L1 divided by 2, L2 divided by 2. Either you can use this formula, right? L1 divided by 2, L1 divided by 2, L2 divided by 2. This is one of the formula. Or you can write L1 dash divided by 2, L2 dash divided by 2 plus BW. That is second formula. Third formula is L0 divided by 6 plus 6 times of DF plus BW. Now out of these three value, whichever is minimum, that will be your answer. Whichever is lesser, that will be your answer, right? Whichever is less, that will be your answer. Clear? So in this way you can calculate the effective flange width for the slab plus beam type, right? So guys, this is already written over here, like BF is effective flange width, L0 is L0 is the distance between the 0 point bending moment, BW is width of web, DF thickness flange, B is actual width. For continuous, L0 may be taken as 0.7 times of L effective, right? Now guys, let us suppose if you have slab plus beam type, which is basically L type, right? In that case, the formula will be L1 dash by 2 plus BW or L0 by 12 plus 3 times of DF plus BW. Now out of these two formula, whichever is minimum, that will be our answer, right? Understood? Now any doubt up to this, guys, please let me know. We have done the design for flagship part. Now we'll start the design for shear. Tell me, crystal clear or not? Please write down. Clear, sir. Shandar. Okay, so let's move to the design for shear part, guys. So the first statement is basically nominal shear stress. How to calculate nominal shear stress? Very easy. First of all, guys, you know the value of working shear stress, and that working shear stress value or shear force value, if it is given, then we are able to calculate the design shear force value. So design shear force value is basically VU is equal to 1.5 times of V, right? Like this. You need to multiply it by partial load factor of safety, right? Which is written as gamma F, and it will be given as per the IS code, right? If you have a live load plus dead load combination, then the factor will be 1.5. If you have dead load plus live load plus wind load or earthquake load, then the coefficient will be 1.2. Okay, so in this way you can calculate the design shear force. Design shear force divided by B into small d. In this way you can calculate the nominal shear stress. Nominal shear stress. Now guys, the next value, which is basically the design shear strength of concrete, which is nothing as tau c. And tau c is nothing as it is the design shear strength of concrete without shear reinforcement. Now this value will depend upon two things. One is percentage of tension reinforcement, and second is grade of concrete. How you can calculate percentage of tension reinforcement? It is very easy. Let us suppose this is our AST. This is B. Let us suppose this is our effective depth small d. So first you need to calculate the percentage tension reinforcement. So AST divided by B into D multiply by 100. In this way you can calculate the percentage of tension reinforcement, and generally in the question they will mention which grade of concrete you have to use, and according to that, guys, or according to that combination, percentage tension reinforcement and grade of concrete, you need to choose the value of tau c. Getting a point? And tau c is what? Design shear strength of concrete without shear reinforcement. The next one is Next one is tau c max. Next one is tau c max. Now guys, my suggestion is don't remember these values. It is not required because it is not possible also to remember these values. They generally provide you in the gate examination itself, right? So please do not remember these values which is written over here. It is not required, but you need to understand how to calculate the tau c in the examination if the data is given. Getting a point? Okay. Next thing is tau c max, which will depend upon the grade of concrete only, right? Only grade of concrete, not on grade of steel. So guys, tau c max is nothing as basically like our maximum shear strength of the beam with shear reinforcement, right? So for M20 it is 2.8, M25 3.1, M30 3.5, M35 3.7. For M40 and above it is 4. Again guys, these values are generally provided in the gate examination itself or in the question itself, right? You don't have to remember it, right? Next, now the question is how we can provide the shear reinforcement in the beam. So there are three options. One is basically vertical stirrup, second is bent up bar, third one is inclined stirrup. So what is our design shear force formula? So design shear force will be VUS is equal to, we can write here, nominal shear stress minus shear strength of concrete without shear reinforcement bracket multiplied by B into small d. So this is our design shear force for which we need to design our shear reinforcement. Okay. Now guys, you know that there are certain condition, right, while going the design. Let me explain that also, then only you can understand it. When you have to calculate this value, when the value of tau v is greater than tau c, then only you can use the above formula to calculate the design shear force. But let us suppose if the tau c value is less than tau v, tau v value is less than tau c. In that case, you need to provide the minimum shear reinforcement. Later on, I will explain that, right? Similarly, we have to check the value, or we have to check the condition tau v is less than tau c max or greater than tau c max. If it is less than tau c max, then it is okay. There is no issue. You can go for the designing part. But let us suppose if tau v is greater than tau c max, you need to redesign the section. Redesign the section, right? Clear? Okay. Now let's move further. Now guys, after knowing the design shear force, there are three options to provide the shear reinforcement. If I want to calculate the spacing for vertical stirrups is basically like this. So what should be the spacing between the vertical stirrup? Center to center spacing between the vertical stirrup is SV. So what is the spacing? How we can calculate? By using this formula. VUS is equal to 0.87 FY into ASV into D divided by SV, right? By using this formula, you are able to calculate the spacing easily. Now what is ASV? ASV is nothing as area of shear reinforcement at one location. Clear? How you can calculate it? Let me give you one example. Let us suppose this is a cross section and this is our shear reinforcement, which is basically 2 lag, right? And this is our AST part. So how you can calculate ASV? So how many lags are there? 2. So that's why you need to write 2 multiplied by pi by 4 into dia of shear reinforcement square. So this 2 is nothing as basically the number of lags which is present in this particular shear reinforcement. Clear? For incline guys, just you have to add one one additional part, which is basically sin alpha plus cos alpha. The above formula will remain same. Clear? Now what is the strength of bent up bar? What is the strength of bent up bar? VSB. What is the strength of bent up bar? Do you know what is bent up bar basically? Please write down. Do you know what is bent up bar? Inclined shear reinforcement should be like this, right? And alpha is what? Basically the angle of inclination of the shear reinforcement with respect to horizontal. If it is not given, kindly consider 45 degree, right? Do you know what is bent up bar? Tau C max will depend upon the grade of concrete directly. If it is mentioned in the question, what is the grade of concrete which we are using, we are able to use the data and we are able to calculate, or we will use directly guys the value of tau C, right? Tau C max from the table itself. Okay. Okay, Shashi. Okay. Now bent up bar is nothing as guys, it is the reinforcement, or it is the main reinforcement which we have bent at certain location, right? So that it will take part to bear the shear force. Simple, right? So what should be the strength of the bent up bar? How we can calculate? Let me show you that. Let us suppose this is our main reinforcement. At this location, if I bend it, right? So this should be our bent up bar. So what is the strength of this bent up bar? So you can write here VSB. So it is 0.87 Fy into ASV or ASB, area of bent up bar, multiply by sine alpha, right? Multiply by sine alpha. So what is ASB? ASB is nothing as number of bent up bar, area of number of bent up bar which you have considered. So ASB can be written as n into pi by 4 into phi square. So n is nothing as number of bent up bar at the one location, right? Okay. And sine alpha is what? Alpha is nothing as again the angle with respect to horizontal. If it is not mentioned, again consider 45 degree as an angle. Yes. It is based upon the compressive strength. Kindly see this. It is based upon the grade of concrete which we are using, and according to that they have mentioned the value, and just you have to use these values directly. Okay, Shashi. Okay, now the maximum spacing of the shear reinforcement, maximum spacing of shear reinforcement which we can allow. It is 0.75 D for vertical shear reinforcement. For inclined, it should be D and 300 mm, right? And there is one more formula, guys. Later on, we will discuss how to use this particular data to calculate the value of spacing exactly. I will explain. And there is one more formula to calculate the maximum permissible spacing or minimum shear reinforcement. So what is that formula? ASV divided by B into SV. It should be greater than or equal to 0.4 divided by 0.87 Fy. Clear? Now guys, let us suppose if I want to check my spacing which I have provided in case of vertical shear reinforcement. So I need to check that data with respect to this formula, this one and this one. Let us suppose by this formula we are getting spacing 1, by this one we are getting spacing 2, by this one we are getting spacing 3. So you need to consider S1, S2 and S3. Now out of these three values, whichever is minimum, that will become our maximum permissible spacing. That will become our maximum permissible spacing. And our maximum permissible spacing, or this particular spacing which you have provided, is less than the maximum permissible spacing. That should be our condition. Then only our design will be okay. Otherwise not. The same thing should be applicable for the inclined shear reinforcement. For inclined shear reinforcement, you need to use D in place of 0.75 D, and the rest two things are same. Clear? Okay. Now guys, if tau is less than tau C, so this is the formula by which you can calculate the minimum shear reinforcement or maximum permissible spacing. AV divided by BSV greater than or equal to 0.4 divided by 0.87 Fy. Let us suppose if tau V is less than 0.5 times of tau C, so no shear reinforcement is required. If tau V is greater than tau C, then design the shear reinforcement. If tau V is greater than tau C max, revise the section. Please remember all these conditions, very important. Okay. Next one is basically the side face reinforcement. So there are two conditions for side face reinforcement. Let us suppose if the depth of the beam is greater than 750 mm and there is no torsional moment on the beam, or if D is greater than 450 mm but it is subjected to some torsional moment, you need to provide the side face reinforcement. So guys, let us suppose this is B, this is overall depth. So side face reinforcement should be provided equally on both the sides. These are basically side face reinforcement. So what should be the area of side face reinforcement? So area of side face reinforcement is 0.1% of web area. Web area means B into D divided by 100. And you need to provide this area equally on both sides. On both the side, you need to provide it equally. Crystal clear? Okay. Next thing is basically our design of slab. So in design of slab, guys, you know that there are two type of slab. One is one way, second is two way. Let us suppose this is our slab. One is shorter dimension and second one is longer one. So let us consider this is shorter. Let us consider this one is LX and this one is LY. So longer span upon shorter span ratio, or the span ratio, if greater than 2, then is one way slab. If it is less than or equal to 2, then it is two way slab, right? Okay. Now guys, let us consider if it is one way slab. So there are two type of reinforcement. One is longer bar and second is shorter bar. Anyone of you who can tell me which is main bar or which is distribution bar? Any one of you who can tell me, guys? There are two bar, one is longer and other is shorter. So tell me which is main bar. This is longer bar, right? So longer bar is main reinforcement or shorter bar is main reinforcement? Shorter one. Very nice. Shorter bars are main reinforcement, right? And longer bar are distribution bar in case of one way slab. Distribution bars. Getting a point? So guys, the spacing between the shorter bar, or you can say that the spacing between the main reinforcement and the spacing between the distribution bar is recommended by the code, which you have to consider as per the data. Listen, for the main bar, the maximum spacing is lesser of 3D or 300 mm, right? Whichever is less, that will be our maximum permissible spacing for the shorter bars, right? You can write here the spacing for shorter bar or main reinforcement is minimum of 3D or 300 mm. Getting a point? Similarly, guys, the maximum permissible spacing for distribution bar is minimum of 5D or 450 mm. Clear? Next one, the maximum dia which can be allowed in case of slab. So let us consider this is our slab and let us suppose this is our depth of slab, which is capital D. This is depth of slab. So the maximum dia which is allowed in case of slab is D by 8, right? The maximum dia of the bar which we can use inside the slab is equal to D by 8 value. Clear? Okay. Next, effective span. How to calculate the effective span in case of simply supported beam, in case of cantilever, in case of continuous? Let's understand it, guys. Very easy. Okay. Let us suppose this is the clear distance between the support, which is nothing as L0. W is nothing as it is our width of support, and D is nothing as it is effective depth of the beam. Okay. So L effective is nothing as L0 plus D, L0 plus W. Whichever is lesser, that will be your L effective. Clear? L0 plus D or L0 plus W, whichever is lesser, that will be your L effective for simply supported. If it is a continuous beam, if it is a continuous beam or continuous slab, so there are two conditions. One is the width of support is less than L0 by 12. And second condition is if the width of support is greater than L0 by 12, right? So let's understand what are the formula which we have to use, right? So let us consider this one is our fixed end and this one is our continuous end. Again, this one is continuous end, and this one is a simply supported end or end support. So guys, if W is less than L0 by 12, then you need to use the formula which you have already used in the simply supported beam. So the same formula is applicable in this case also, right? So how to calculate the L effective? In any of the cases, right? Whether it is fixed or continuous or simply supported and continuous, right? Okay. So in any condition, whether it is this one, whether it is this one or whether it is this one, you need to use the same formula L0 plus D or L0 plus W, whichever is lesser, that will be your answer when W is less than L0 by 12. But let us suppose guys, if W is greater than L0 by 12, then there are two conditions. When one end is fixed and other is continuous, that means this is fixed and this is continuous, or both end continuous, or either this one. So L0 is equal to L effective itself. L0 is equal to L effective itself, right? But let us suppose if one end is continuous and other is simply supported. So you need to use the formula which is basically L0 plus D by 2 or L0 plus W by 2. Whichever is lesser, that will be your answer for this particular span. Crystal clear or not, guys? Please write down in the chat box. Are you able to understand all the things which I am discussing over here? Please tell me guys in the chat box quickly. एक बार सभी लोग बता देंगे बच्चों की जो मैं बता रहा हूं वो समझ में आ रहा है, क्या आप रिवाइज कर पा रहे हैं सही तरीके से, तो मजा आएगा यार बात करने में. The speed is good or it is too fast? Please let me know guys. The speed is good or it is too fast? Please write down in the chat box quickly. Okay guys, okay. So let's move further. Now let us suppose guys, if we have a cantilever beam, right? For cantilever, what should be our formula to calculate the L effective? If it is cantilever, one end is free, other is fixed. Let us suppose this is our effective depth of the beam and L0 is the clear distance between the support and the end. So L0 plus D by 2 is the formula. But let us suppose guys, if we have one end continuous, another is free. So in this case, our formula will get changed and it will become L0 plus W by 2, right? And that is our formula to calculate the L effective again. Done? Very nice. Now, if you have a portal frame, then what is our formula to calculate the L effective? It is center to center distance between the columns, right? So center to center distance between the column will become our L effective. Very nice. Now there is one relation guys, which is recommended as per the limit state of serviceability to limit our vertical deflection, right? And what is that formula? Please remember this formula, it is also important. Span by small d value should be less than or equal to a value, right? Now, as per this formula, we are able to assume certain value, or we are able to calculate the minimum requirement of the depth of the beam, right? Now, let us suppose if your span is less than or equal to 10 meter. Let us consider the span of beam is less than or equal to 10 meter. Then you can use this formula, and this a value is nothing as it will depend upon the different type of beam. If it is cantilever, it is 7. If it is simply supported, it's 20. If it is continuous, it is 26. Clear? But let us suppose if our span is greater than 10 meter, then you need to multiply the a value by 10 by span. Okay? If span is greater than 10 meter, then kindly change the formula. Span by d is less than or equal to a value, but this a value should be multiplied by 10 by span. Don't forget to write the span value in meter over here, right? Clear? But this particular factor is only applicable in case of simply supported beam and continuous beam. Please do not use such formula or such modification in case of cantilever beam. Not applicable for cantilever. For cantilever, it is not applied. Clear? Okay. Next, minimum tension reinforcement, maximum tension reinforcement, maximum compression reinforcement. So guys, very simple. Let us suppose this is your cross section of a beam. This is our tension reinforcement, AST. This is our ASC. This is B. This is capital D, and this one is small d, right? If I want to calculate the percentage of tension reinforcement which we have provided, so PT provided can be written as AST divided by B into D multiplied by 100. Okay. But let us suppose if I want to calculate the minimum percentage tension reinforcement which is allowed. So PT minimum, you can cancel this. PT minimum is 0.85 divided by Fy into 100. In this way, you can calculate the minimum percentage tension reinforcement. What is maximum tension reinforcement which is allowed? 0.04 B into D. B into capital D, not small d. Okay, which is nothing as 4% of overall cross-section area. Similarly, maximum compression reinforcement, ASC max, is 4% of overall cross-section area. Crystal clear? Let's move to the next part. Reinforcement for the slab. Minimum AST which is required in case of slab. So if you are using mild steel, it is 0.15% of B into D. B into D. Let us consider this is our B and this is our depth. Usually guys, while calculating the area of steel for the slab, we'll consider 1 meter as a width of slab, right? For which we are trying to design it. So if it is not given what is the value of B, you can consider 1000 mm, right? So 0.15% of B into D for mild steel. If you are using HYSD bar or CTD bar, then it should be 0.12%. Clear? Next, the maximum spacing of the main reinforcement and the distribution bar, this is already done. The maximum die of reinforcement, this is already done. We have already done it, right? Earlier. Let's move to the next one. Now, for two-way slab, guys, for two-way slab, we have divided the edges, right? Or we have divided our slab span. So basically, the length of the middle stirrup is 3/4 of Ly, 3/4 of Ly, and the edge stirrup length is Ly by 8. Ly by 8. Similarly, in this direction also, you need to divide it. This is Lx by 8 edge stirrup. This is 3Lx by 4, which is middle stirrup, and this is Lx by 8 again edge stirrup, right? Now, very important thing: corner reinforcement or torsional reinforcement. Corner reinforcement or torsional reinforcement. So guys, this end is, or this edge is discontinuous, right? This edge is also discontinuous. This one is continuous edge. This one is, sorry, this one is discontinuous. Let me erase it. This edge is discontinuous again. This edge is discontinuous. This edge is continuous. This one is continuous. This one is discontinuous. This one is continuous. This one is continuous. So please remember guys, the condition for torsional reinforcement or corner reinforcement is at least one edge should be discontinuous. Or you can say that guys, torsional reinforcement or the corner reinforcement is provided when we have two edge as a discontinuous or one edge discontinuous, other is continuous. But if you have both edges are continuous, then no need to provide any kind of torsion reinforcement. So when the section or when the portion of, or the corner of the slab will have two edges as a continuous, no torsional reinforcement required. No torsional reinforcement required. Getting a point? But two edge discontinuous, then you need to provide the torsional reinforcement in 4 layers. 4 layers, right? And the dimension of this particular 4 layer will be Lx by 5, Lx by 5. This should be the dimension. That means it is in the form of square, right? So each layer will have an area of reinforcement which is 3 by 4 of AST positive X, right? This should be the area of reinforcement which is required in each layer. Getting a point? But if you have one is discontinuous, other is continuous, so in this case again you need to provide the 4 layer over here, but the area of steel in each layer will become half of this value, 1 by 2, 3 by 4 AST positive X. Clear? If you have both as continuous, no torsional reinforcement required. The same thing is applicable for this also, right? This particular condition will be applicable over here also. Crystal clear or not? Tell me, guys. Then we'll move to the next thing, which is basically our development length. Please write down quickly. Any doubt, any doubt, any doubt? Please write down. Please write down. Please write down, guys, quickly. Any doubt if you have, please write down, or it is clear to all of you. Please write down, guys. Up to this, it is crystal clear. Then we will move further. Clear? Very nice. Now the next thing is basically the development length. What is development length? It is nothing else. It is the minimum length of reinforcement which is required to capped in the concrete so that the strength of bond is not less than the strength of reinforcement, right? Now guys, this is nothing as this is our development length which is represented by LD. Now what is the value of this LD? That is the question. Let us suppose the dia of reinforcement is phi and the tension force is T. Okay. Now guys, the formula which is recommended by IS code is 0.87 Fy into phi divided by 4 times tau BD. Now what is tau BD? This is nothing as tau BD permissible. Tau BD permissible, which is recommended by IS code. Okay. So 0.87 Fy into phi. Phi is what? Nominal dia of bar. Tau BD is permissible bond stress or design bond stress. And what is LD? That is our development length. Now this tau BD value will also get fluctuated on the basis of type of reinforcement, on the basis of condition of the reinforcement, which type of force is there, whether it is tension or compression. According to that, it will change. So guys, this particular value which is written over here is valid when you have Fe 250 grade of steel and the bar is in tension, right? Then only you have to use these value which is written in the table. But let us suppose if the bar is HYSD bar, then you need to change the permissible value, right? Our value should increase by 60%. So our permissible value will become 1.6 times of tau BD. But let us suppose if our bar is in compression, then you need to increase the permissible value by 25%. That means tau BD will become 1.25 times of tau BD permissible. Clear? Done. Now guys, these are the value which is for LSM and this one is for WSM. But you don't have to remember, guys. It is my suggestion. Don't remember it. And if you want to check this thing, guys, what you can do, whatever PYQ you have solved, right? Kindly observe whether you need these values from the IS code or it is given in the question itself. You are able to understand whether you have to remember it or not. Okay. Next thing, next chapter is basically our column, and then after that, the last chapter will be pre-stress. Okay. So column, the main this particular member is mainly designed to take the axial load, and it is a vertical member mainly, right? And the strut is nothing as basically it is an inclined member or a horizontal member which again take the axial force only, right? Now there is one ratio which is known as slenderness ratio or slenderness limit, which can be written as L effective divided by least lateral dimension. What is least lateral dimension? What is least lateral dimension? Let us suppose this is our column, right? This is our column. So one value is L effective. What is L effective? Later on we will discuss, right? B is what? B is basically least lateral dimension. These two dimension will be lateral dimension. One is B, second is D. So this one is, let us suppose, lesser. B is less than D. So we can call this as least lateral dimension. Least lateral dimension. What is D? D will become larger lateral dimension. Larger lateral dimension. Getting a point? Okay. Now guys, if L effective by B is less than 3, that is known as pedestal. If L effective by B is greater than 3, less than 12, it is short column. If L effective by B is greater than 12 but less than 60, it is cylindered column or long column. Now the question is, what is L effective? L effective is nothing as our effective length of the column, which can be calculated on the basis of K into L. L is what? Unsupported length of the column. Unsupported means if you remove the support, what is the total length of column? That is unsupported length. K is what? It depends upon the support condition, right? Now it is written over here, guys. Just you have to remember the conditions. If both end fixed, please remember these values, which is recommended by IS code. You need to remember this. You need to remember this, right? It is very important. Recommended value of effective length as per the IS code. Both end fixed, it is 0.65 L. One end fixed, other is hinge, 0.8 L. One end fixed, second is partially, means you can say that it is restrained against the rotation but not held in position. This is 1.2 L. Both end hinge, 1 L. Guys, this is most important condition. This is most important condition. This one is also important one. One end free, other is fixed. It is 2L. One end hinge and second is not held in position. So again, it is 2L, right? But guys, please remember these four condition, which is most important. One is this one, both end fixed, 0.65 L. One end hinge, other fixed, 0.8 L. Both end hinge, 1 L, and one end free, other is fixed, it is 2L. Please remember these four only, which is required. Okay. Next, as per the IS code, we have certain assumption which should be applicable in case of column also. So you need to remember these assumption, which is very important. One, the maximum permissible strain in the concrete in axial compression is 0.002. If it is maximum permissible strain in concrete in bending compression, how much it is? Tell me guys. For bending compression, what is the permissible value? Please write down in the chat box, all of you, and let me know the correct answer quickly. Tell me guys quickly. Tell me. 0.0035. 0.0035. Very nice. Now guys, there are two type of strain value in case of column. One is highly compressed fiber and second one is least compressed fiber. Let me show you that. What is that condition exactly so that everyone can understand it. Let's suppose this is a column. And let us consider our load is placed at a certain eccentricity with E. Right? Now there are two type of effect which will come over this particular column part. One is direct compression, second is bending also, right? So one is basically P, which is basically direct compression, and second is movement, which is should be like this, P into E. Now tell me guys, this particular fiber will have most highly compressed fiber and this one is least compressed fiber, yes or no? Because due to direct compression, we will have compression on this side, and due to bending also, this particular fiber will get compressed. But on this fiber, we will have compression, then we have tension due to the bending condition. That's why it is highly compressed fiber and this one is least compressed fiber. Getting a point? So as per the IS code, the strain in the, right, the maximum compressive strain at the highly compressed fiber is subjected to axial compression and bending when there is no tension on the section shall be 0.0035 minus 0.75 times of strain in the least compressed fiber. This should be the formula. Please remember this, it is important, right? Sometimes they will ask you, right, what should be the highly compressed fiber strain, right, as per the IS code. So you need to remember, it is 1 mark problem, right? Okay. Now what is the minimum eccentricity formula? So you know that, guys, it is not practically possible to apply the load exactly along to the longitudinal axis in case of column. That means certain eccentricity is still there while loading the column, and due to that eccentricity we need to check that particular value as per the IS code. So what is our formula to calculate the eccentricity? E is equal to L, unsupported length of the column, divided by 500 plus B or D divided by 30 or 20 mm. So whichever is more, that will be our minimum eccentricity. Clear? Next, the design of short column. So the ultimate load carrying capacity by the column when minimum eccentricity condition is there. So our formula will be PU is equal to 0.4 FCK into AC plus 0.67 FY into ASC. Now what is FCK? You know that. What is AC? AC is net concrete area. Net concrete area. And what is ASC? Net area of compression steel, or you can write here compression steel area. Clear? Clear? Now let us suppose, guys, if our eccentricity is 0, that means our load is exactly present along to the longitudinal axis. Then in that case our formula will become 0.45 FCK into AC plus 0.75 FY into ASC, and this is known as ultimate load carrying capacity by the column, right? Now if you have a helical reinforcement, so there are certain conditions which you have to remember. Helical reinforcement, in case of helical reinforcement and a circular column, the load carrying capacity by the column will increase by 5%. That means our formula will get changed 1.05 times of 0.4 FCK into AC plus 0.67 FY into ASC. This will become our formula, right? Let us suppose the spacing between the helical reinforcement is nothing as our pitch, and this is represented by P. Now this pitch value will have certain condition that we'll discuss. Okay. Okay. So let me add some more point first, then I will discuss the pitch value also. Okay. Now listen, guys. The minimum area of steel in case of column, is 0.8%. Please remember these values, very important. 0.8% is the minimum area of steel which you have to provide in case of column. The maximum percentage of steel is 6% if it is labbed. If it is not labbed, how much it is? If it is not labbed, how much it is? What will be our permissible value? Tell me, guys. If it is not labbed, then what should be our permissible value? Any one of you who can tell me? Quickly write down. 4%. Very nice. 4%. So guys, what do you mean by lap condition? Lap means, let us suppose if the length of reinforcement is not available, right? So in that particular case, what you have to do, you need to overlap the reinforcement like this, right? And not lap condition means our reinforcement is a single bar like this. Clear? For lap condition it is 6%, and for not lap it is 4%. Okay. The minimum dia of bar which we have to use is 12 mm. That means this is the minimum dia which we have to use. Minimum number of bars in case of rectangular column 4. For circular it should be 6. Transverse reinforcement. What is transverse reinforcement? Let me show you that. This is our longitudinal reinforcement. Then we have transverse reinforcement. These are transverse reinforcement, right? So the dia of transverse reinforcement is what? Dia of main divided by 2 or divided by 4 or 6 mm. Whichever is more, that will be your dia of transverse reinforcement, this one, right? Now the spacing of this transverse reinforcement, what should be the spacing between the transverse reinforcement? So the spacing between the transverse reinforcement is least lateral dimension, which is B, least lateral dimension, which is basically B, second 16 times of dia main, but dia main minimum. What do you know minimum? Let us suppose if you are using two different dia of main reinforcement, one is 20 mm, second is 18 mm. So what you need to use over here, you need to use 18 mm in place of 20, right? Next one is 300 mm. So out of these three value, whichever is lesser, that will be your permissible spacing. Whichever is lesser, that will be your permissible spacing. Clear? Done. Next thing is basically pitch. So guys, this permissible pitch value should be greater than 25 mm and less than 75 mm. Less than 75 mm. Clear? Next thing is, next permissible condition is 3 times of helical reinforcement dia, but it should be less than dia of core divided by 6. Dia of core divided by 6. So let me explain it also. Guys, the outer to outer dia will be the gross dia of the column. DG is nothing as gross dia. Gross dia of the column. Now how you can calculate the core dia? So this is our core. You need to calculate or you need to consider what is our clear cover. So this is clear cover. In case of column, what is the value of clear cover? Any one of you? Any one of you who can tell me, guys, what is the clear cover in case of column which is allowed? Any one of you who can tell me? 40? 40? If it is not given, can you consider 40 mm, right? So guys, after considering 40 mm, we are able to calculate the dia of core, which is basically DG minus 2 times of clear cover, right? So this should be our core dia. Core dia, right? So core dia divided by 6, right? And this is our dia of helical reinforcement. Phi H is dia of helical reinforcement. Clear? Okay. Let's move to the next chapter, which is basically the pre-stress, last chapter. So let me explain some formula first. Pre-stress concrete. Last chapter, guys, then we'll close the session. Pre-stress concrete. So for pre-stress concrete, guys, very simple thing. Let me explain with a basic one. Let us suppose if you have a beam in which the cable is straight and exactly it is present at the center. So what should be the stress at the top and the bottom? It is very easy to calculate. Let us consider the cross section is B cross D. And at this junction, we will have our cables, right? So what should be the stress at the top and at the bottom? It is P by A. Very easy. P by B divided by D, right? Okay. Second condition, guys. Let us suppose if we have a straight cable, but it is present at an eccentricity of E. At an eccentricity of E. This is P, this is P. At an eccentricity of E, the cable is present. Now let us suppose, guys, if I want to calculate the stress at the top fiber and at the bottom fiber, how I can calculate it? Very easy. First of all, please remember certain formula, guys, and according to that you have to apply it. First one is direct stress, which will be coming P by A. Second is bending stress due to the pre-stressing force, and that will be PEY by I. Next one is the bending stress which is due to the applied load. Let us suppose due to some movement or due to a live load or dead load, we'll have some movement and due to which we'll have some stress, MY by I, right? If I ask you guys at the top fiber, let me write here, this is basically end and this is basically mid span. Okay, so wait a minute guys. At end, at top fiber, at top fiber, what should be our stress? So it should be plus. Please remember, in case of pre-stressed concrete, compression is positive, so it is P by A, right? The next value is basically what? PEY by I, and it is what? Tensile at the top and compressive at the bottom. So if it is tensile at the top, it should be negative, minus PEY by I, right? Now at the bottom fiber, what should be our value? At bottom fiber, it should be P by A plus PEY by I. Clear? At midspan, at midspan, at top fiber, the value will be P by A minus PEY by I. Then we have moment, and due to this moment guys, at the top we will have compression. That's why you need to write plus. So My by I. Then at the bottom fiber, the value will be P by A plus PEY by I minus My by I. Clear? So in this way you can calculate the value of stresses at the top and at the bottom fiber in case of straight cable with some eccentricity E. Let us suppose guys, if you have bent cable, so bent cable can be converted into by a load balancing concept, right? Let's suppose this is our bent cable. So what you need to do guys, you need to make this cable as a straight, right? And our cable will become like this, and the eccentricity will be E, and this force will become P cos theta. You can replace this P cos theta by P directly, and we have to apply one force which is 2P sin theta in the upward direction, right? So what should be our M net? The rest of the formula will remain same guys. Okay, so M net will be equal to how much? It will be the moment due to this load W and the moment due to this 2P sin theta, right? So due to this W, what will be our moment at the center? WL square by 8. What is the moment? Or let us consider guys, this is our point load W, and this is W net, which is UDL. Kindly consider this one is point load so that it will be very easy to understand. And this one is a UDL. Okay, so one is W net, WL square by 8. Second one is W minus capital W minus 2P sin theta multiply by L divided by 4. In this way, we are able to calculate the net moment. Okay, after calculating net moment, you have to follow the procedure to find out the stresses at the top fiber and the bottom fiber, right? At the mid span and at the ends. Now, let us suppose if you have parabolic cable. So in case of parabolic cable, if you want to make it straight by using load balancing concept, you can do it. But your cable will become at this particular location with some eccentricity E1, and this force will become P cos theta. You can consider it as a P also. Okay. Then we have a dead load and the live load at the top, but at the bottom we will have the WP, and this WP is nothing as it is the UDL which is caused by or which is applied by the pre-stressing force, right? Because you have changed this particular cable in a straight way. That is the reason. So what is this value of WP? Anyone who can tell me guys? WP L square divided by 8 is equal to P into H. This is the formula. What is H? H is nothing as E1 plus E2. E1 plus E2, right? So what is the value of WP? WP will become 8PH divided by L square. This is our formula for WP. Clear guys? Clear, clear, clear. Please write down. Clear? Any doubt? Any doubt? Any doubt? Any doubt? Please write down guys in the chat box. Crystal clear to all of you? Please write down guys. Otherwise I am not able to understand. Okay, let's understand the last thing, which is basically the type of losses. Type of losses. So guys, basically there are various type of losses in case of pre-stress. One is basically loss at the time of tensioning, loss at the time of tensioning. Second, loss at the time of anchoring. At the time of anchoring. And the third one is subsequent losses. Subsequent losses. Okay, in subsequent losses guys, we will have a various condition, like due to elastic shortening, due to elastic shortening. Second one is due to creep of steel and creep of concrete, creep of concrete and creep of steel, creep of concrete due to creep of steel. Then last one is due to shrinkage of concrete, due to shrinkage of concrete. Clear guys? So these are the losses which you have to follow while in calculation of your pre-stress losses. So let's understand the formula guys once and we'll close the session. So first one is loss at the time of tensioning. The formula will be, let me write here. The formula will be PL is equal to P naught mu into X plus or mu into alpha into K into X, right? So what is PL? PL is nothing as loss of pre-stress. P naught is initial pre-stress. Mu is coefficient of friction between the cable and the duct. Alpha is basically the change in gradient, right? If both end is tensioning condition, if both end is tensioning, then you need to use alpha is equal to how much? If both end is tensioning, then the alpha will be 8H by L, right? And if it is one end tensioning and means only one end tensioning, then in that particular case guys, our value will be 4H by L, right? Okay, K will be our constant, right? And X will be our the distance between the point of consideration. Now loss at the time of anchoring, that is basically anchorage slippage. So we can calculate the loss of pre-stress will be change in length due to slip divided by L multiplied by ES. Clear? Let's understand the last thing, which is basically the subsequent losses guys. So in case of subsequent losses, the first one is basically elastic shortening. So for elastic shortening, you know that guys, the value will be what? M time FC, right? M time FC. M time FC. And what is FC? That is the stress at the level of cable, at the level of cable, right? Due to creep of concrete, what will be our formula? Due to creep of concrete guys, the value will be phi m time fc. What is phi? Basically creep coefficient. Now due to creep of steel, the value can be in between 1 to 5%. Generally it is taken as 3%, right, of the initial pre-stress value. And due to shrinkage of concrete, so there are two formula guys. For pre-tension, condition, the formula is 3 into 10 raised to power minus 4 into ES. For post-tension member, the formula will be 2 into 10 raised to power minus 4 divided by log to the base 10 T plus 2 multiplied by ES. So this is the loss in case of post-tension member due to shrinkage. Clear? So these are the formula guys which I want to discuss over here. and I think you are able to understand it very well. So any doubt if you have, please write down in the chat box, guys. Any doubt if you have, please write down in the chat box quickly. Otherwise, we'll close the session and we'll meet in the next one. Any doubt, any doubt, any doubt? Okay, guys, so that's it. Let's meet in the next session. Tomorrow we will discuss the 10 predicted question for gate examination of our structure analysis. So kindly join that session, guys, also, in which you are able to understand all the things. Okay, let's close it, guys.